Okay, Grace, we're recording for you today and for Anna, and Alex, and yeah, everybody else. It just decided it's optional Tuesday apparently. So yeah, not him. Okay, particle moves according to the law of motion. S is equal to F of t for t greater than or equal to 0, where t is measured in seconds and S is measured in feet. So what we're going to do is we're going to start off by finding the velocity at time t. How do I find the velocity? Take the derivative. What rule do I have to use to take that derivative? The division rule, the quotient rule. Good, good. I use the quotient rule, okay? So we'll set this up. I'm going to use a scratch area to do this because I don't have a lot of room to work. So I'm going to go S of t is equal to, what, 4t minus 10 we got? Over t squared plus 3? Okay, great. So I'm going to look at that. I'm going to take the derivative, so v of t, or s prime of t, is equal to, how do I do the quotient rule? Derivative top, good. Good, t squared plus 3. 2t. All right. Oh my goodness. Bottom squared, whole thing. Ridiculous. Okay, that's the derivative. Now, we're going to put it in a little bit more simplified form. Okay? And so, as I get in a simplified form, I've got 4t squared plus 12 minus 8t squared plus 20t. So v of t looks like it's going to be negative 4t squared plus 20t plus 12 all over t squared plus 3 quantity squared. You good? This one? This one? This. I took the derivative, so we just said the derivative of the top. Derivative top was 4 times the bottom minus the derivative of the bottom, which was 2t, times the top. Better? Divided by the bottom squared. Yes? F prime g minus g prime f all over g squared. All right, excellent. So I'm going to put that back on this sheet over here, where we have the velocity at time t, v of t, is equal to a negative 4t squared plus 20t plus 12 all over t squared plus 3, that quantity squared. At this point, I'm going to use my graphing calculator for every portion. So I started out by doing the quotient rule by hand. Now I'm going to use my graphing calculator for every other portion. On the back side of the worksheet, the last two problems, you're going to want to use the graphing calculator for, okay? Come on, calculator. Everybody's waiting on you. Yes. I don't. I'm sorry about that. Jeez. There's some batteries in the dumpster. There's also some sitting at the landfill. If you want to... Sounds like Katie's really concerned about your hygiene and safety. Okay, so what I'm going to do is I'm going to type in both functions. And I have to make sure I use parentheses in the appropriate spot. We'll get rid of that guy. Up here, I'm going to have parenthesis 4t, 4x minus 10, divided by parentheses x squared plus 3. And then, for y sub 2, I'm going to plug in the derivative. And the derivative is parentheses negative 4t squared plus 20t plus 12 divided by x squared plus 3. Sorry, I'm interchanging x and t here. And I've got that one. Everybody okay with that? Any issues? Okay, so I'm going to go over to my highlighter here. And I'm going to take this highlighted portion off. So I just see the first function. I'm going to try to get a good picture of the first function. Is everybody okay with that? Zoom standard. Hope I can see it. Cool. Looks like I can. I'm going to change my window so I see even a better picture. What is the minimum x value that I need to see in this problem? What's my domain? 0. So I'm going to put -2 for my x value so I for sure see everything. We're going to go all the way until time 8, so 10 would be enough. Tick mark every one. My y values, when you looked at the graph, it looks like it goes down to about, say, -4. And so I think a -5/3 graph is going to be plenty to be able to see it. And now I get what I think is a very, very nice picture of the graph. Everybody okay with that? Okay. So I'm going to try to sketch that. It looks like it crosses somewhere around 3. And it looks like it crosses somewhere around -3 there. So this is S. This is the position function. And now I'm going to ask you some questions that will really kind of poke at your brain. See if you really understand what's going on. Don't be afraid to answer these incorrectly. We're in the midst of learning right now. I'm going to point to a spot on this graph right here. For those watching, we'll say the red dot right there. If I'm at the red dot, can anybody tell me if I'm traveling forward or backward? Make a case for me. Okay, so this is the position function. If you want to determine whether you're traveling forward or backward, forward is when the derivative is positive. Is this the derivative or the original? This is the original. So in order to look at the derivative, you would have to look at the slope. Because the slope is positive, it is traveling in the positive direction. Traveling forward or backward? Still forward. Forward or backward? Backward. So would you agree at this point right there, somewhere about there is where it changes direction? Okay. So if at this spot is where we're expecting it to change direction, you tell me what should I then notice about the graph of its derivative at that spot? Crosses the x-axis. How about before this spot? Before it crosses the x-axis, if I look to the left of it, it should be above, and afterwards it should be below. So I'm going to make sure that, I check for that as I look at the derivative. So let's go in here, and now let's go to the derivative. Okay, I'm going to put an enter on the equal sign, and I'm going to go up here and press enter on that equal sign to take it off. So now I'm going to look at the graph of, we'll do this one in black. We're going to look at v of t, which is s prime of t. That's the derivative of the position function. And I'm going to graph that guy. Hard to see it the rest of the way, isn't it? Looks like it really gets close to the x-axis. If you want to see a different kind of graph, obviously you can go to Format, and you could take your axes off if you want to see the entire graph, and it will do the same piece, but it shows you it really does look like it flattens out around the x-axis. Okay, you see that? But we said that we were pretty confident that it actually crosses the x-axis at some spot. And so I'm gonna try to make sure that we can see that. I'm gonna again go to Format, And I'm going to go to axes on, just like that. Look at the graph again. We're expecting, we thought it would cross somewhere around like that 4.5 spot, right? Okay, and if you zoomed in around that 4.5 spot, my guess is that you would see it. I'll zoom in as a box, and we'll see what we can get. Most of your graphs will be much more obvious than this. I'm just giving you one that you would have to think a little bit more critically at. So 5, 6, 7. I'm going to try to go all the way past 8 because if I do any function computation, I'm going to need that. And, oh, do you see a duck underneath? It sure did. It's hard to see it, but it did just barely duck underneath that. Looks like it happens at 1, 2, 3, 4. Yeah, right about 5. Right about 5. So I'm going to try to draw that graph over here. Looks like it crosses right about 5. Looks like it goes up to about, 2 or something like that. And then it kind of flattens out. Okay, positive direction or negative direction? Why? Because you're above the x-axis. The derivative is positive. This is the derivative. Okay? Yeah. Okay? So you got to understand which function you're looking at. Okay? And we'll do some practice there. All right. Excellent. We're going to fly through this. What is the velocity after 3 seconds? Going to use my calculator. What would you do? Yeah, plug in 3. Now, you got a couple options. Second, calculate value, and just hit 3, and it'll give you that right away. Or what you could do is you could, go to your table. But you could see I get 0.25. So velocity after 3 seconds, v of 3, is equal to 1/4 what? What's my label? Does it say we're measuring feet or meters? Feet per second. When is the particle at rest? Well, that's when the derivative is equal to. So look for where v of t is equal to 0. And I have my function right here. Looks like it's equal to 0 right about there. We're going to find it exactly. How would I find it exactly? So I can calculate what? 0, number 2. So left bound, I need to make sure that I'm above the x-axis. As you can see, your y value is positive. That means I'm above the x-axis. I'm going to press enter. Now I'm going to move right until I go below the x-axis. You can see that your y value is getting close to 0, and we want to make sure it gets negative. And sure enough, it's negative here. I can tell I'm below the x-axis. Press enter. Your calculator does an incredible operation, which is actually go back and find that spot, which is 5.541. So at time equals 5.541 seconds. Now, I will say for good practice, every time I find a decimal like that, I always go to 3 decimal places because that's what's required for you on the AP exam. When is the particle moving in the positive direction? Well, that is whenever the derivative v of t is greater than 0. So looking at the graph, can you tell when the derivative is greater than 0? Between what values? 0 and 5.541. Everybody agreed? So you have 2 ways in which you could express this. You could say, from 0 less than or equal to t less than 5.541, or you could say from 0 to 5.541. Okay? You could put an interval notation, or you could write it as an inequality. Now, if you use parentheses, that would be absolutely fine. But I want to make a case for you right now so that you understand why I included 0. Watch this. If I go to my calculator and I calculate the derivative at 0, do I get a positive value or a negative value? That means at 0, it will be traveling in the positive direction. Okay? So from the outset, it starts with an initial velocity. Okay? So that's why I included it. I would not mark that wrong on the test, though I do think you should understand the nature of why I included it. Find the total distance traveled during the first 8 seconds and draw a diagram to illustrate the particle motion. Question. Yes. There's a couple times where you can do it by hand, but it's a little bit more challenging. So in this situation, I don't know how you would do it without looking at the graph. See what I'm saying? I mean, I kind of have to look at the graph here to determine that. All right, question. One or the other is just fine. I wrote down both, I believe, on the answer key so that you can express it however you would like. On the AP exam, they would allow for either or. Okay? All right. Find the total distance traveled during first 8 seconds and draw a diagram to illustrate. I'm going to start with the diagram, and I'm going to look for these pieces. The start, the change, and the end. At what time does it start? 0. At what time does it end? And how many times does it change direction? Just once, and that happens at 5.541. So those are all time pieces. What I need to do is I need to come up with distance pieces or position pieces. Well, if I look back into y equals, which one produces for me position, the top one or the bottom one? The top one. So at this point, I need to go back in here. I need to unhighlight this one, and I need to highlight that one. You could highlight them both, I guess, technically, and then when you're in your table, you would have both functions pop up. But for the sake of this, I'm just going to do one. And we just type in 0, 5.541, and we'll also type in 8. And you can see the pieces that we get. It looks like at time 0, it's located at negative 3.333. And at time 5.541, it's located at 0.361. And at time 8, it's located at 0.363. I'm sorry, idiot. 0.328. I'll draw the diagram of the motion. This is negative 3.333. We have 0. We have 0.328. And we have 0.361. Some people wonder where to go. You do it chronologically. So this is at time equals 0. This is at time equals 5.541. And this is at time equals 8. So we follow it chronologically, starting at time 0. We travel to time 5.541, and then we travel back to time 8. And that's the motion of the particle. Let us end by finding the total distance traveled. First travels 3.333 in order to get from there to 0. Then it goes from 0 to what? 0.361. Then plus whatever 0.361 minus 0.328 is, right? So that's what I'm going to have to calculate. 3.333 plus 0.361 plus 0.361 minus 0.328. 3.727 feet. Now, as we end and you have the rest of the time to work on your assignment, I want you to understand this. When I first taught this problem, I would have the students do most of the work without using their calculator. We would use the quadratic formula and pieces like that. As we got introduced into the AP exam, this is a problem where they would probably require you to use your calculator. There are many problems on the AP exam where you cannot do them without the calculator. 50% of the exam, you're allowed to use your calculator. 50% of the exam, you're not allowed to use your calculator. That's approximate. Probably more like 60 you are and 40 you aren't. But anyway, it's good practice to make sure you're using your calculator properly. All those functions are available. And trust me, this is relevant. It will come back. We will see this motion again. Make sure you know how to do this. It's the first question you're going to get on your test. All right. Everybody on YouTube Nation, have a great day, and good luck with your assignment, guys. Get to work.